All right. How's it going, everyone? Good. My name's Travis. I'm going to be going through modules and testing with you guys today. How has the first week been so far? Is everyone getting, comfortable in the space? It's going smooth. JavaScript's going well. Nice. So like the slide says, we're going to be looking at modules and testing. And specifically, this involves modules, looking at exports, which is how we kind of create a module, require. That's how we are going to import a module into another file. We're going to look at NPM. We're going to look at unit testing. And then we're going to look at a few tools for unit testing, specifically that being Mocha and Shy, which I'll do a demo today, but you'll also be able to use in some of your activities today as well. So just to start off, what is a module? Any thoughts from you guys? Have you guys started to encounter modules? It's something you've heard of before. What is our current understanding of a module? Cool, so no thoughts on it right now, but that's good because we're going to learn about it. A module is a way of encapsulating some functionality or code so that it can be used in other JavaScript files. Modules are a general concept across different programming languages. We're specifically going to be looking at it in JavaScript, but in other languages, in other contexts, there are also modules. And when we make modules, the benefits that we get are that we have files with clear and separate purposes. It reduces the amount of code in a single file. It makes code usable across multiple different files and contexts. And it only exposes what a file does, not the how the file does it. So just maybe more straightforward, when we have modules, we can have files that are like short. I don't know if some of you are programming so far, you've started to get like longer files. It can maybe get a little bit messy. You're having to scroll down and see like where you're working on or find certain places in the file that you've like are trying to add things. Modules makes that a little cleaner. It makes it so that one file has a specific purpose, and we can flip through different files easily to find the specific thing that we're looking at. We have a lot of repeat ability with modules. It keeps our code dry. If I write one function and I want to use it in different pieces of my code in different files, a module lets me do that. I don't have to copy and paste that into my different files. I can just import it and use it anywhere I want. The last one, this one's probably, I haven't written it the most clear, but the idea that it only exposes what a file does is not how is the benefit if I'm working with multiple people or even for myself. Once I make a module and I expose like the functions or the things that it does, someone can use that module without necessarily knowing how it does all of those things. I can say, hey man, I have this module, it has a function, and it's going to calculate the area under a curve. All you need to do is give it like the equation of the line, and it'll spit back out like exactly what you need to know. The person who uses the module doesn't necessarily need to know how I've implemented it, what my algorithm looks like, but they can use it just based on that. Sorry. Okay, sorry about that, Calgary. I totally slipped my mind there. Thanks for letting me know on that. If you could just keep watching that Calgary channel, see if they have any questions or anything, and letting me know. Just for Calgary's benefit, I'm going to briefly go over what I've already said. And you guys. All right. Sorry about that, Calgary. So just to refresh, but we haven't covered much, but I introduced that today we're looking at modules and testing. And specifically, we are looking at modules, and part of modules is knowing how to export a module, create a module, how to require a module, which is how to import a module and use it in other files. We're going to look at NPM, which is a node package manager. And finally, we're going to look at unit testing and two tools of unit testing, Mocha and Chai. And we were just, when you guys caught up with us, looking at what a module was. So a module is a way of encapsulating some functionality or code so that it can be used in other JavaScript files. And the points that we are breaking down of those benefits of doing modules is that we have files with clear and separate purposes. It reduces the amount of code in a single file. It makes code usable across multiple different files and contexts. And it only exposes what a file does and not the how. The major benefits of this is that we have files that are smaller. We don't have long, winding files that we need to be searching for a specific function or searching for a specific area that we're needing to add new content. It makes it so that we don't have to repeat our functions across a bunch of files. We can make it in one module and use it wherever we need. And just to start off, we're going to be making a small application. So I'm just making a directory called code. And inside here, I'm going to make a file called Pokemon counters. So the application that we're making is going to take in a Pokemon type, like fire, water, grass, and it's going to output what the counters are to that type. So in Pokemon, it's kind of like a rock, paper, scissors game. Given a certain type, they have certain weaknesses. And we just want to make that easy for someone to see what the weaknesses of a certain type are. So in my editor, I'm just going to open up that folder. And I'm going to create a new, yes. So here's our file. So like we were saying, we want this file to have a function, and that function will take in a type as a string, and it's going to output the weaknesses or counters to that type. So we are going to call this function Pokemon counters. It's going to be a function. Takes in one parameter, and like we said, it's going to output the weakness to that counter or to that type. Now, because today we're looking at modules and testing, we're kind of going to motivate our function in a test-driven way, or test-driven development. So before we implement what Pokemon counters does, we're going to create a test for it, so that when we implement it, we can right away test it and see if it's doing what we want it to do. So if I run this soon to be implemented function and I give it the type of fire, and I save the output into this current variable, fire return, I want to test first if fire return has a length to it. and I want to see if that return is greater than 0. Because up here, our output, we said we want to output the weaknesses or counters to a type. And maybe the easiest way of doing that is to output it as an array. So if we have an array here, my example could be like water, grass, any type of types that it would be. So afterwards, I'm checking to see if this return from our function, which will be an array, if the length of that is greater than 0, because we want it to be. And then inside this, I want to test if the fire return, so this array, includes the correct things. So for a fire Pokemon, the counters are water. And we also want the fire return to include ground. And we want to return the sand, dirt, rock. There we go. Okay. So our test, we are checking first that it's returning something of some length, and second that it's returning the correct thing. So if it returns the right thing, we're going to console log just a string saying Pokemon counters returned the correct counters for fire type. Else we can console log incorrect counters were returned. Also, if nothing is returned, that's also incorrect. All right. So now we have our little testing stuff here. Testing. Let's actually try and implement our function. So to do this, we're going to have an object of all of the weaknesses of types. For simplicity, we're going to stay with generation 1 because there's like way more types now. And even within generation 1, we're just going to do a couple types to start off. So we have fire as our example. And we already said that those weaknesses were water, ground, and rock. We'll also add water. So weaknesses are grass, electric. I have a list here. Yeah, just those two. And we'll add grass as well. The weakest of the 3 starters apparently because it has way more counters. Okay. Now, given our type, so this will be a string, we want to check if it exists in our weaknesses object, and if it does, we want to return the array of its weaknesses. So if weaknesses, square brackets of type, and we can remember that if I go weaknesses dot fire, this is the same as doing weaknesses square brackets of fire. The difference being that the first one, I have to know exactly the property's name that I'm trying to access. So I use .fire, and it looks for the string fire as one of the properties, or as one of the keys. With the second, when I'm using square brackets, I can give it a string like this and look for fire, but I can also give it a variable. So in our case, type is a variable, and I would not be able to use this first syntax for it, but the second syntax, I am able to dynamically grab one of my key value pairs from my object based on what the type is. So if my type is given water, weaknesses with the square brackets and type will access the value grass and electric. So if we have something in our weaknesses object, then we want to return that thing. Else, for now, we're just going to return an empty array. So right before we do some testing, we're just going to console log our output to see what we're testing. And in our terminal, we are going to go so let's get this a little bit. There we go. We can see from our output, our function spat out the correct thing, water, ground, rock, and our test correctly said that Pokemon counters return the correct counters for our fire type. So it looks like our function is going well. It also looks like our test is going pretty good. If we wanted to, we could duplicate this test, and I guess I'll also need this. And we can do this, a similar test for water. We'll have to change water. And our counters for water were grass and electric. Water. And just to see that that's working. So nice. We have our function returning the correct counters for fire and water. If we wanted to continue our test-driven development, we could be adding more tests for more types. And as we're doing that, adding more weaknesses in our function. So this is nice. We have a little application going, but quickly we can see that it's kind of becoming a bit messy. At the top, we have our actual implementation of what we want to do, but at the bottom here, we have all this testing. And as we keep adding testing and more implementation, for me, it's becoming very messy. It's hard for me to organize myself between the actual function I'm creating and my testing. And it also, the file's purpose doesn't really make sense. I'm both testing and using the function in the same page. After I finish my testing, am I going to erase all my tests and like start adding, maybe allowing for user input? There's different things I could do to use this code. But if I have my file set up as it is right now, I'm going to have to be removing stuff and changing it as I go forward and move from testing to more of like a development case. The other thing that we might have noticed is that the way I'm testing here is probably not the most concise way. And also, readability-wise, when I run my test, I mean, we have an okay output to know what's going on, but it could be clearer in terms of how well my tests are doing, how they're passing, and things like that. So we're going to be able to look at both of these. First one, we're going to be trying to solve through modules, and the second one, like I said in the intro, we're going to be looking at testing with Mocha and Chai. So the first thing, we want to know how we make a module. And module creation involves two parts. It involves exporting. So with a Node.js JavaScript file, the module keyword is a special object that represents the current module. So in any file, as long as it's a Node project, if I write module, it is a reserved keyword that is an object, and it has things that represent the current module. So that sounds a little abstract right now, but we'll go into more practical examples and kind of understand it a bit more. So one property of that module object is exports. And it is an object itself that specifies what the current module will export. So what the current module will be giving or offering to other files. By defining a module, I'm saying, this is the contents of this file, and this is what I want other files to be able to access from this file. And that's done with module exports. So just as a review, a module represents, well, the module keyword within a Node file, a Node JavaScript project, represents the current module. And a property of that module is exports, and that tells the module what will be exported. So if in one file I have module exports, by default it's going to equal an empty object. If I do nothing to module exports, if I don't even add anything to it, if I don't even bring it up in the file, I don't even mention the keyword, its default value is an empty object. But I can change what that object has. I can give it a new property. I can say, within this object, I want a key to be thing, and I want the value of that key value pair to be something. Then in another file, I can import that object, so this empty object here, or this object that has one key value pair, with require. Require retrieves the module that exports from the specified file and makes it available to the current file. And the syntax for that is here. So the quick example we can look at, so in file A, we have module.exports. We're having the whole exports equal a string. In file B, if we require that file A, this variable, which we are requiring into, which we're storing our require, now is equal to hello. It's equal to exactly what we exported in file A. So here, we set the exports to hello. When we require it, our required variable is now equal to hello. Similarly, if we, in file A, we have module.exports.1, we're assigning a key of 1, the value of 1, and a key of 2, the value of 2. If we require this module in file B, then we're going to have numbers. So this is where we saved our import. This is where we required it to. Is going to be equal to an object with two properties, 1 and 2, with the values 1 and 2. So let's look at a real example. So like I said, this is getting a little convoluted. Let's take all of our testing right now and just comment it out. So now our Pokemon counters file is just the function itself. Let's make a new file. We will call it Pokemon counters test. And in this file, we're going to create a variable called Pokemon counters module. And we're going to set that equal to, using the require keyword, the module that we want to require. So it's in our root directory, and it is right there, Pokemon counters. So having done nothing else besides just require that file at this moment, if I console log, Pokemon counters module, and I run that file, what do you think it's going to output? Yeah, it's an empty object. Because like we discussed, I don't mention module or module exports in this file, but the default value of module exports, so default value is that empty object. But if I want to be specific about what I'm exporting, I can say module.exports, and I can say I want to give one property called 1. I want to give another property called 2. In my test, I'm requiring it, and I'm printing it out. So now I should see I have an object, and I have one property 1 with the number 1, one property 2 with the number 2. The default for my export is an object, but I can also overwrite that if I don't want to be exporting an object. If I want to be exporting just a single value or maybe a single function, instead I could go module.exports. The whole exports is going to be just a string. So in my test file, now I just have hello there. It's not an object, it's just a single value. Yeah. Yes. You're going to have like a hard time getting a path to it if it's some weird place. For now, we're looking at just requiring modules, so other JavaScript files. We can also do things to require, say, like a text file or a JSON file, and we'll get more familiar with that later. But yeah, requires flexible. I can give it, any path up or down that I have access to. So yeah, we're flexible with what we can export. It can be a single thing, it can be an object, it can be, literal. It has many things that we can do with it. But for our purposes, we want to export our function right now. So what we can do is we can say, I want to export that function as Pokemon counters, and I want to set that to my function Pokemon counters. So on the left side of this assignment, Pokemon counters is the new key that I'm assigning for this object. And on the right side, Pokemon counters is referencing this already created function. So this is a reference to this function we created. This is just the new name I'm giving it inside the object. So if I go back and run my test, I see that I have an object with the key Pokemon counters, and it has a function called Pokemon counters. So that's nice. Now I can kind of have separation between my actual function and any testing that I want to do. I'm going to take all this testing stuff that we had down here. I'm going to remove it from my Pokemon counters module, save that, and I'm going to paste it in my testing file now. I will uncomment it. And now I have separation between my program implementation and my program testing. One last step before I use it though. Right now I have a variable Pokemon counters module, which is an object that has a function inside of it. Throughout this test, I'm using Pokemon counters as a function. So what I can do is create a new variable, Pokemon counters, and set it equal to my Pokemon counters module dot my Pokemon counters. So because my Pokemon counters module is this object here, if I want to specifically just get that function, I can dot access it with Pokemon counters. So on this line, I have Pokemon counters module, which is that object, and I'm specifically getting just the function from that object. I'm saving it in a variable Pokemon counters, and throughout my tests, that's the function that I'm using. So now if I run my test, I have the same kind of output that we were getting before, except now it's in a different file. It's using my function correctly, and we get the water, ground, rock, and we also see that for both fire and water, we're getting the correct output. Yeah, so the question was, this Pokemon counters module, is it referencing the module exports from this file, so the object that was here? And yes, that's exactly what it's doing. So whatever this whole module exports, in this case object is what Pokemon counters module will be. It's what this require function is returning. So it's returning whatever the current value of module, or not the current value, but the final value of module exports is for the specified file. Are there any questions up to this point? Does Calgary have any questions? I'm going to keep building on this example. But at the very end, my plan is to go back and we're going to go line by line and just kind of review the whole flow of it. So by all means, any questions as we're going, but if it starts to get something I went over and wasn't quite clear, I'll definitely come back to it as well. But this is nice. So for now, we have our test and our function separate. The other nice thing is now, what if I want to actually have a user be able to use my function? If I create a new file and I say, what is the counter to? And in this file, I also want to use that function that I created. In my test, I can copy this same require code. And now in this new file, I also have access to that function. And maybe in here, I want to do, I want to get an input from the user. Do you guys remember how to get input from a user? There's one in JavaScript called process.argv. And that's an array that includes all of the lines I type into the terminal. So that includes node, that includes Pokemon counters test. And if I include some information after that, here, it'll include that. I don't really care about these first two ones. I'm more concerned about what the user types after that. So I'm going to specifically grab that one, which is the third input or the second index in the array, 0, 1, 2. And let's get the result from calling Pokemon counters with our input. And if the result, the the length is greater than 0, so something was returned. We're just going to console log we'll do input has the counters, and then we'll just add on our result. If nothing's returned, we'll just console log invalid type for now. So now if I run I called it what is the counter to JS, and I give it fire. I see fire has the counters water, ground, and rock. I can also still run my test, which also uses the function, and get how the tests are going. So I have two files, both requiring the functionality from my Pokemon counters here. So this is a small example, but in a bigger project, you can quickly see how with one module, I can get so much more use out of it. Whoa. So next thing we're going to look at is NPM. And NPM stands for Node Package Manager. It's a tool that helps us download and interface with Node packages. So if it's a package manager and we're dealing with packages, then what is a package? So a package is one or more modules grouped together to serve a common purpose. Where a module is a single file, a package is a collection of files packaged together. People create packages and publish them for others to use. This lets other people or us use packages and code instead of having to write similar code ourselves. So we get the benefit of, thousands and thousands of other people writing code for useful things. If we also want to do that same useful thing, we can just use their stuff and use it right in our project very easily with packages and NPM, or Node Package Manager. NPM has an index of like all the packages that are publicly published. So we can search, Chalk is one we'll be using in a bit. It has a big list of all of the packages that have the keywords Chalk. If we click on the first one, we can see specifically that this is a package. You see how to install it, how to use it. So for any of the packages, we can come to this site and search for them and get all the documentation that we need in order to use it directly in our project. So Chalk is terminal styling done right by their keyword, but specifically it just lets you print out some like colors in your terminal. But there are tons of packages. As you're moving forward with web development, there's a lot of packages that are specific to web development that'll be helpful in creating servers and doing HTTP requests and tons of different things. So packages are really, really helpful. If I go to that package we just looked at, GitHub, we can kind of see the anatomy or the breakdown of what a package looks like. So these are all the files in a package. Is that big enough for you guys in the back? Yeah. We can see that there's a README. The README has information on what the package is and how to use it. There's a bunch of files here. Index, some JavaScript files. The one important file that we're going to look at that is universal to all packages is this one here called package.json. So package.json is kind of the fundamental thing that a package, a node package needs in order to be kind of considered a package. So if we look at this package.json, like the file extension says, it's a JSON file. So it's a stringified JavaScript object. We can see the open curly bracket here, and we see a bunch of key value pairs. The package.json is kind of like a manifest for a package. It gives a bunch of general information and configuration things for the package. So here we see things like the name of the package is Chalk. The version is 2.4.1. We've got a description, a license. We have what engine it's going to be used on, so it's a Node application. We have something called scripts, files, keywords. And then we have these two properties here, dependencies and dev dependencies. These are two properties that are very important to the package.json file. Because the package ecosystem is so big and there's so many different uses for packages, we have a lot of interdependent packages. We have a lot of packages that require other packages in order to work. So for instance, Chalk, in order to work, also requires the package ANSI styles. It requires another package, escape string regular expressions, regex. It requires a package called supports color. So this lets NPM, or the package manager, know that when it downloads or uses Chalk, that it's also going to need to make sure that it has these packages. So dependencies are all the other packages that a project or a package itself depends on. The second one here, dev dependencies, is similar, but these are dependencies that this package requires for development. So as developers, as we're creating our own projects, there are some packages that we only need to use as we're creating the project itself. Once we're done and we ship it off to like a customer or a user to use, they don't need to be worried about some of these things or any of these things. But as we're creating it ourselves, they're things that we need to use. So dev dependencies are usually things like testing frameworks, things that help us test, things that help us configure our project as we're creating it. Maybe it's a logging thing that records logs or information about how our code is running, lots of things like that. But we have both of these, dependencies, dev dependencies. The other ones that we see here, keywords, files, scripts, are not as important. We'll probably get more used to them and seeing how they work as the weeks go on. But for now, the main things we should be concerned about are dependencies and dev dependencies, and kind of the basic information stuff about the package. Any questions on packages or NPM up to this point? Yeah.
So does JavaScript, so I come from like I learned Python before I learned JavaScript.
Yeah.
And in Python also as a concept of a package.
Mm-hmm.
In like Python language itself, it means like, does JavaScript have something similar? So, or is it only about NPM and like dependencies? Like, is there a way to reference, say, the root of a package or something like that, or is it just
So the question was whether in JavaScript there is packages outside of the scope of NPM, whether you can innately in the JavaScript language itself reference other packages. I guess the short answer is like no. NPM is the main package manager for JavaScript. It lets us use packages as they look, and we've looked at here. In pure JavaScript, there are ways to include files, and there are ways to do modules. The way that we've been looking at so far with export and exports and require, that's a very Node way of getting modules, and NPM is a very Node way of getting packages. With general JavaScript, we can import things like jQuery, which is just a full library for front-end development. it's done a bit differently and it's not done as a package. For now, I'll leave it at that. If you have time, I can look into it a bit more. But in terms of packages being a bundle of files, a grouping of files together, NPM is the way that it's done in JavaScript, not implicitly in the language itself. Yeah, no worries. Cool. So these are things we kind of just went over, but a package.json is information about the package or project. It has general information as well as information about configuration and dependencies. Configuration being how your application runs, configuring things about the environment in which the program runs, things like that. Dependencies are the other packages that the current project depends on and requires in order to run properly. If we don't have something in those dependencies list, the idea is we're going to get an error somewhere because it's needed. So packages are great for us to use other people's code, to use useful things, but we also can use packages and specifically NPM with our own projects. So to be able to use a package ourselves, we also have to initialize our current project as a package. This is done with npm init, and that creates that all-important package.json file in the current folder, which lets the package manager know that the current folder is a node project. Following that, if we want to use other packages, we have to install the package itself, and there are a few ways of doing that. So to install a project or a package in our current project, we can use npm install, this being whatever package name that we want, with the flag -- save. This will install the package as a normal dependency. If we run npm install package name with -- save - dev, this will install it as a dev dependency. So both of these will update the package.json file to list the newly installed package as a dependency, whether in that dependency property or the dev dependency property. And it will download the package to the node modules folder, creating it if it does not already exist. The other option for installing a package is npm install package name with the flag -g. So this is going to install the package globally for your whole computer, making it accessible anywhere. This is generally used if the package provides command line tools and it's not something specific to your project. So there are specific node modules that aren't used within files like this, but they're just used in the command line to provide tools for development, to do nifty things in different ways. So looking at our project that we have up to this point, I'm in the correct folder for it. If I type npm init, this is going to initialize our current project as a node project, as a node package. So after typing npm init, it's going to run me through a couple questions to build out that package.json file. If I just hit enter through all of it, it'll just go with all of the defaults, but I have the option of customizing it. So the first one we have is name. It takes the folder's name as the default, so it's just going to call this code. I mean, we can be fine with that for now. Version, default version is 1. Description, we can say we can give it whatever description we want. The entry point, so what is the main or starting file in this project? We can just leave that there. Test command, we'll look at test commands in a little bit later. We can specify what Git repository we want this to be associated with. If we want to add any keywords, we want to say who the author was, license, and then it shows a kind of like a preview of what our package.json file is going to be, and if we just enter, it will have created it. Here, we now see this package.json with these contents. These are all of the options we just went through. Right now, we don't see that dependencies or dev dependencies property, and that's because we haven't installed any dependencies. So maybe we should install some. So we said npm install the package name. So in this case, we're going to use that package chalk that we looked up on the npm page, and we want to save it as just a normal dependency. Install chalk save. I hit enter. It's going to give us a short loading screen there. Bigger packages would take longer time. And if we look in our package.json, we now see it's been updated to include chalk as a dependency. The other thing we'll see is in my project folder, I now have a new subfolder called node modules. This folder has ANSI styles, chalk, color convert, color name, escape string, regex, has flag inside of it. So you might think, oh, well, we just wanted to install chalk. Why are all these other things in there? Well, like we looked at earlier, chalk has its own package.json, and it has its own dependencies. So when I installed chalk, npm is smart enough to look in dependencies, and it installs all of the other dependencies that chalk needs. And even inside of those dependencies, it'll look for any nested dependencies. So if escape string regular expressions requires a couple other dependencies, we'll see those installed in here as well. We don't really have to concern ourselves with what is in node modules, as long as we know that we have the correct dependencies in our package.json. Node does or npm does all the heavy lifting for us on that side of things. So now that we have chalk as a dependency and it's downloaded in our node modules folder, we can use the module in any of our files. In our what's the counter to, which is our file for getting user input and running our program, we can go var chalk, and we can require chalk. So the first thing, maybe you notice the difference between how I required something here and how I required something here. When I was requiring my own module, I was very explicit in where the path was. So I'm saying it's in the current folder, which is /, and it's called Pokemon counters. When I'm requiring chalk, I'm just saying it's called chalk. I'm not specifying that it's in node modules. The reason for that is Node, by default, first checks in node modules for whatever I'm requiring. And if it doesn't find it there, then it will look in the general folder directory of my project. So it's smart enough when I require chalk, it will be there. So if I console log chalk then, and we run this, this is what I've just required. It has chalk, it has a constructor, another thing called supports color. We don't really know what that means, but we see that the module or the package itself has been required. Yeah.
So for the first required statement, if you omitted the // it would still work. It would just check the node modules first to see if there's a Pokemon counters.
So if we do that, we're going to get an error. Because it will check the node modules folder first, but then it's not smart enough to check the root folder. It still is going to be looking for a path, and so it just is going to come up empty.
Does that require for that's the file name? Does it need the file extension at all, or obviously doesn't care?
Yes.
Or is it rather
Yeah, exactly. That's a good point. So I can include the file extension for all of these. It's not going to hurt anything, but the function is smart enough to assume that any file without an extension is a JavaScript file. So later, if we're trying to import other things, we might have to be explicit in the file extension. But for these files, because they're JavaScript, we can just omit the file extension. Okay, so chalk, like I said briefly before, lets us put output to the terminal with some colors. We can make our program a little nicer to look at by giving color coding some of the types. So to start off, I'm going to create an object called colors, and it's going to have a bunch of key value pairs of the type and what color I want them to be. So if I have fire, I want that to be red. If I have water, I want that to be blue. If I have grass, green, and if I have electric, I want that to be yellow. We'll leave it at that for now. So the way I use chalk is let's just do a test before we go into it. If I do chalk dot and then a color, I could do blue, and I give it a string test. It should take this string, color it blue, and then my console log will spit it out into my terminal. So right here, we have test, and it's some blue font color. I can go pink. Oh, maybe there's not a pink. I can go yellow. Yeah, and we get some yellow font. So what we're going to do is we're going to have the user give a type, and if our function correctly returns the right counters, we're going to console log the type that they said in a color appropriate to the type. So we can go chalk, and then we want to go dot whatever the color is, and then we want the input, which is a string. The problem is our color is going to be dynamic. We don't know at this point what the actual color is, so we're going to need these square brackets to just determine it. Like we said, anytime we're accessing an object's property and we don't know the actual string name of that property, we can use square brackets to dynamically choose what it is. So dynamic in the sense that this is going to be a color, red, blue, green, yellow, from our colors object. So from our colors object, we're going to grab the color based on our input. So I know this is kind of confusing looking because we have a lot of nested things, but let's break down kind of what this resolves to. So we have that, which is the same as chalk. So colors of input is this object looking for a property based on whatever this input is. So let's say our input for this is water. So then colors of water will be blue. So then that above is the same as this. And chalk square brackets blue of input is the same as chalk dot blue of input. So this statement here that we're using, if our input is water, kind of gets resolved to just being chalk dot blue of input, which would be chalk dot blue of water. So let's test that we're using it correctly. We have what is the color to water, or what is the counter to water? Water in blue has the counters grass and electric. if we wanted to, we could loop through the counters that are returned, giving a color to both of these types or any type in the list that is returned. For now, we won't do that. I think it wouldn't be the most interesting thing for me to do for you guys, but that would be nicer, probably, user interface. And I'll get rid of this. Any questions on that? So this kind of the overview of the steps we did. We initialized our project as a node project or a node package. That created our package.json. And then we used npm to install a new package or a new dependency for this project. In doing so, it added a new property to our package.json dependencies, listing the dependency that we installed. And it also added chalk to our node modules folder. If our node modules folder didn't exist, which in this case it actually didn't, it would create it as well. So we don't need to worry about making this or handling it. npm will do all of that stuff for us. Yep.
So what happens if you say you have a dependency that you know the name of, so you put it in the dependencies? How do you install that new package that you just put in, or can you?
Yeah. So our question was, because package.json is just a file, we can edit anything in here. So we could manually edit this dependencies property and say add another package. If we know the package name, we can just type in the package name. So that's a very good point, and it is something that we can do. So let's look. There's another package called Yoda Say, and that lets us output things with a little like Yoda or Darth Vader, but the package name is just Yoda Say. So if I, in this package.json file, type in Yoda Say, and we need to give it a version. So the current version is 1.1.9. We'll see if that works. Now our package.json has the correct dependency listed, but we don't have it in node modules. Luckily, npm knows that these type of things happen. If I run npm install in the folder of the project, npm is going to look into this package.json. It's going to look at all of the dependencies, and it's going to one by one check if the package is installed. If it isn't, it's going to install it and all of the dependencies that it looks. It'll update node modules based on whatever my dependencies are. So if we run that, we see that it's downloaded something. Let's look. It says Yoda Say, and then it has a bunch of other packages is downloaded that we're dependent, or that Yoda Say is dependent on. If we look in our node modules, we see does not appear to be there.
Why is the syntax different? Like for chalk, you have the power sign.
This one? So for versioning, there's different symbols to mean different things. I think this is called a caret symbol. It means I want to install chalk up to version 2.4.2. So it'll install any version that it can up to and including this version. We can look at version characters. There's a couple other ones that are helpful. No, there's only a few that can be used. So tilde matches the most recent patch version. Caret, this up, matches the most recent minor version. So that's different. So the let's get this a bit bigger. The major version is always the so 1.2. That would be the major version. The minor version is down to the third numbers, 1.2.3. So with tilde, any version up to the 1.2 range, so 1.2.3, 4, all the way up, will be matched. And with caret, any version up to the major will be matched. So this could be up to like 1.9.9. It's based on just controlling the version that you want. Packages do change over time, and newer versions. The idea behind major and minor versions, a minor version change should not have any changes that will affect your project. So if they update from 1.2.2 to 1.2.3, it should be 100% safe to use that same package. When there's a major update, so if we go from 1.2.3 to 1.3, the reason it's a major update is because there are new things in the package that could change how you use it. So the question was, do you need to know the difference between dependencies and dev dependencies? So the difference in what they mean is that dependencies are all the dependencies that your project will need to use to run. Dev dependencies are dependencies that your project needs while you're developing. It could be testing, it could be trying things out. In terms of how they work, if I download, say you made a project or package and I download it and I want to install all the dependencies, if I'm using it just to, in production to use it, NPM will not install the dev dependencies. But if I'm also a collaborator, I'm building the project itself, I can also install the dev dependencies. So the separation allows it to be smart. If I'm using it just as a normal user, I don't need to also download all of the dev dependencies. The dev dependencies could be large in size. It's something that I might not necessarily want to do, but if I am working on the project, then I can also easily download all of those things. It's tracked in one place. Okay, so we were looking at the mystery here. We had, oh, okay. So we're getting a warning, 1.0, no repository field. Oh, there we go. It just had not updated. So we have all of these new packages installed now because of, oh no, we don't. That was the old one. Let's see what happens if we just install it normally. Yeah, so I think, I'm not sure what this warning is, but maybe Yoda say is not working for Ubuntu. Let's try a, yeah. Let's try a more straightforward one. Oh, I think I have. Yeah, I'm not actually sure why this node modules folder is not updating. Because I think it is being installed. Let's look. So, Lodash require Lodash. So if I run this, yeah, we're not getting an error. So our Lodash has been installed. I think my text editor is just not updating the folder properly for some reason. But we'll look at that in a sec. But like you said, if I update this manually, I can just install all dependencies with npm install. And in fact, this is kind of the practice that we want to do when we're sharing projects and working with each other. I don't want to send you a project that includes this whole node modules folder, because this node modules folder can be really big and it's also really easily replicated. So if I want to send you the whole project really quickly, I can send you the project without node modules, and then you can get it, and when you get the project, you're just going to run npm install, and you'll get that full folder replicated on your machine, and you'll be ready to run. It's much faster for you to run npm install than for me to upload the project with all of the dependencies myself. Okay. So we're going to take a quick break. I think we only have enough time for, we'll come back at 10:30, so we have like 9 minutes. And if you think of any questions in the meantime, please come back with them. We'll answer some questions when we come back. And then we're going to look at some testing stuff when we get back from the break. Thanks. I think it's just the houses. All right. Any questions that came up what we were thinking during the break, or anything I can go over quickly before we go into unit testing? Cool. So what is unit testing? As this picture kind of shows, it's dividing a problem into pieces and individually checking if each piece functions as it should. Practically, this can be as simple as testing whether a function, given a certain input, returns the correct input. So our test right now in here, this is kind of a crude attempt at unit testing. Our unit is the function, and we're testing different cases on how that function performs given certain input. So two tools we can use for unit testing are Mocha. So Mocha is a JavaScript test framework for Node programs. It helps to organize and manage our tests, and we'll see what that looks like in a sec. And the second one is Chai. So Chai is an assertion library. It provides easy syntax for describing how we want things to look or be. Again, that's not the clearest sentence, but let's look at a small example. So we're including the Chai package here, and we're specifically using part of Chai called assert. Assert lets us declare how a certain value should be. So for this first one, we're saying foo should be a type of, and then the second parameter is what the type we want it to be, so string. This will return true if the assertion is correct, and it'll throw an error if the assertion is wrong. So in this case, foo is a string, so our assertion will pass. We can also pass in an optional message that will be passed in the error that is thrown if it doesn't, or the message that will be shown if the assertion is successful, and it will negate it if it is false. There are other assertions we can make, like equal and length of. Equal checks if, again, the first parameter being the value we're checking for, and the second parameter being what we're asserting it to be. So we want, in this case, our variable foo to be equal to bar. The last one, we want our variable foo to have a length of 3. This is, in general, what assert does. It gives us flexible ways of specifying what we want a value to be. We specified its type. We specified specifically what it should be equal to. We specified its length. Depending on the unit that we're testing, there are all different types of outputs. Sometimes it won't be as straightforward as being, we want it to output an exact thing every time. Maybe our test is whether it's the right length. Maybe our test is whether it's the right type. Assert allows us to form these tests with a bunch of different ways and with kind of clear syntax. I'm asserting that it is a type of string. I am asserting that it's equal to bar. Yeah.
Does Node have like a native assertion?
Yeah, so Node does have a native assert. So if we're just using Mocha by itself, we can still assert things just with Node. The benefit of Chai is that its assertion library is bigger, and Chai also includes an expect library as well. So assert these. This is kind of the demo we just looked over. That's big enough. But we also have other ways of doing assertions or other ways of checking values with Chai. The main one being expect. So these are some examples of how we use expect. We expect given value to be a string. You could get by with using the built-in Node assertion library, but it's good to start getting practice with Chai now, because as you grow your test, you're going to be wanting to use this expect side of Chai. We're not going to go into expect in this lecture right now, but just as that's a good point that the node itself has an assertion library. We're looking at chai because you'll probably end up using it for not its assertion library itself, but the other things that it also offers. This one? It wants. Sorry, what was? Oh, I see. So the question was for this one, how come foo and bar are being equal to each other? So the reason is foo is a variable in this case, and up here they've kind of snuck in that its value is bar, the string. And so equal is checking if its value, the string bar in this case, is identical to the value given here. So it's checking, is it also a string, and is its contents equal? So if this was not bar but foo, it would not be equal. It's looking for same type and same actual value. So that's what chai does for us. Yeah, the assertion fails, chai throws an error. So I think it's nice on these testing ones to get a practical example. In our project, we're going to install Mocha, and we're going to install it with the save dev flag, because these are both dev tools. They're tools that we're only going to be using for testing. We're not going to be using in actual production. So and then we're going to install chai. Much quicker than the first one. And if we look in our package.json, we see now under dev dependencies, we have two packages, chai and Mocha, exactly what we wanted. So to use Mocha, which is our framework, Mocha likes our tests to be organized in a certain way. And the way it likes our tests to be organized is in a subfolder called test. And in this subfolder, we can make tests. So we'll call this test.js. And in this file, we're going to require both Mocha and we're going to require chai. But specifically, we want the assert part of chai. And let's do a console log of, is this working? So Mocha as our framework is smart enough that if we, in our package.json, we have a set of things here called scripts. So scripts is any script that we can run from our command line with Node. So let's see. Node knows that a project is initialized in this folder, and it knows that this scripts thing exists here. So when I run npm test, npm given a keyword will look in scripts for the keyword test, and it will run the script associated with it. So in this case, we get error no test specified and exit 1. So that's exactly what it's printing out here. Instead of that, we want to replace this with Mocha. So with Mocha installed as a dependency and my test script set to Mocha, Mocha will run, and Mocha's smart enough to look in our test folder and run our test file. So if I do npm test now, we see that's running Mocha. Down here we see 0 passing. So this is a Mocha thing. It's looking through our test.js file for Mocha tests and is letting us know how many passed. We don't have any Mocha tests in there right now, so we have 0 passing. And we know that that file was run because we have this console log, is this working, that we set up in there. So let's overview that just quickly. We installed both Mocha and Chai. They appeared in our package.json under dependencies. We made a folder called test, and inside of it, we put a JavaScript file called test, where we require both Mocha and Chai. In our package.json, we changed our test script to Mocha so that when we run npm test, it runs Mocha, which is smart enough to look in our test folder and run our test file. So now that we know it's targeting this file correctly, I can show you some of the framework that Mocha lets us do. So the first function that Mocha has is describe. So describe's purpose is to give some text to let the tester or let the user know what the test is for. So for this one, we're going to say it's testing our Pokemon counters module. So we give it some string which describes what the test is, and then we provide it with a function to run. So we can nest our describes. So outermost layer, we're testing the module, and in here we're testing the, or we can just define it like this, the Pokemon counters function. So this is what we're testing here. If we had more functions inside of our module, we could have different describe blocks for each function. Inside describe blocks, we can have it blocks. So its are where we actually do the assertions. We actually say how our function should return. We're making the test itself in here. So we say it, and then we say should return. We had water. Water, ground, and rock. Given type fire. So in here is where we can use our Chai assertion stuff. So actually, we don't want to name it Chai. We want to name it assert because that's how we're going to be using it. And first, we want to be able to get the result of running our Pokemon counters on fire, because that's what we're testing for this specific it block. But to use our function, we're going to need to include it just like we required Mocha and Chai. So if you remember here, we include the module, and then specifically we get the Pokemon counters function from that. But instead of being in the same directory, it's one up, so we add the second dot. And we're testing, getting a result on the fire, and then with that result, we want to assert that it includes, include, nope, just include. So that result includes water. We also want to assert that it includes ground. We also want to assert that it includes rock. So now if we run our test, yeah. Great, so the question from Calgary was, why don't we need to call describe with mocha.describe? So up here, when we're requiring chai, we're saying from this chai package, let's get assert. So why don't we also need to do describe? Or to get different things, or similar to here, like we have require and Pokemon module counters, we're getting like a specific thing from it. So the difference being that we're not just running this test file alone, we're running the test file with Mocha. So in this, when we do test Mocha, it's using the Mocha package to go into test and run this test file. So because Mocha is running itself, it has access to describe. It has access to it. It has access to the framework that Mocha has. That's the same reason why when we ran it without anything in the code, we have this thing down here that says 0 passing. So if I ran this file just normally, I wouldn't see this green 0 passing at the bottom. I might just see this text here. But because I'm running it with Mocha, I have this 0 passing, and I also have access to describe and it and the other things inside here. Yeah, so without require Mocha, let's run npm test. We see that it's letting us know Mocha is running it. It's testing Pokemon counters module. It's testing the Pokemon counters function, and it should return water, ground, and rock given type fire, and it's passing. So yeah, we don't even need this module up here because, again, we're running it in the context of Mocha. So good point. We don't need that. And that is why we didn't need to specifically get describe and it from Mocha. If it were the case that we needed this, we would have to get describe from it and get it from it if it wasn't run with Mocha. That clarify things a bit? Yeah, including this definitely made things a bit more confusing. My bad on that side. Yeah, so we saw actually, because I just ran this, that this is how Mocha is letting us know about our tests. It gives both of our describes so that we know that we're testing the module, we know that specifically we're looking at the function, Pokemon counters, and we're seeing whether or not our assertions passed. So our it statement, which was should return these things, was passed. If we go in here and say that it should include just a random string, and we run the same test, we see 0 passing and 1 failing. So our function here should return these things given type fire. There was an assertion error, expected all of these, and or expected our result, which was this, to include this string that we wanted. And it didn't get it. So it's very specific in how our test failed and in where it failed. So So this is nice, especially when our tests get bigger. So right now, because this is just like one small test, it maybe doesn't seem worth the effort. But trust me, as your tests get bigger, as your units get more complicated, as you're wanting to do more complicated assertions, having a nice framework like this to show you exactly how you want to do your tests and to provide nice, clear feedback can be very helpful. So if we do 2 more really quick, given type water, we want it to return electric and grass. Grass. Oh man, and the water one was super long, or the grass one was super long. Bug, fire, flying, ice, and poison. Bug, flying, fire. And the last thing, we need to make sure that we're getting the correct results. So this is grass. This is water. Oh, sorry. This is grass. And this is water. Okay. So we've added 2 more test cases for our same function. So it's in the same describe because it's the same function. But they're different cases, different input for each one. And we'll run our test one more time. We have 2 passing, 1 failing. So we see for the function, it should return water, ground, and rock given type fire. Failed. And then the 2 passing were should return electric and grass given type water, and should return bug, fire, flying, ice, poison given type grass. So at the bottom, we can see all of our fails and see what was wrong. Assertion error expected. Given this, we should have also included this long string. So again, that's because we left this as this gibberish string. But it's kind of a nice format. It makes it nice for describing our tests and seeing which ones passed in a clear way. Any questions on either Mocha or Chai and how they're being used here? You'll get some chance to work with both of them today in some activities. But for sure, any questions now that I can help with. Cool. So the question was, the tests I have laid out here, they all run independently. So this one checks one. So yes, they do run independently. And then the second part was, well, if they're running independently, is there a way to run them non-independently so that if one fails, it doesn't check the rest? Or maybe we need to make sure that they pass together or they don't pass at all. Yeah, there are other ways to do tests. You can provide for this whole describe. I can, set how some certain variables should be before running all of them. So I can set a context for all of the tests. I could say that maybe all of these are on the single input for this. There's different general descriptions, and then I'm individually testing each one. In terms of testing this one and then not bothering in testing the rest if the one fails, off the top of my head, I don't know the syntax for that, but in general, Mocha has a lot of different ways you can do testing. So if you're going to be using it for testing, you kind of just have to get your hands into the docs and dig around and see what ways it can work for you. Yeah, no worries. Any questions from Calgary before we wrap things up here a little bit? Well, that's it for my lecture this morning. Thanks for working through it with me. If you have any questions on any of this stuff or anything else, I'll be around for a bit. Feel free to ask me. I will be posting all of this code as well as the notes we went through in the lecture notes and on GitHub, and I'll provide that information for you. Yeah, thanks everyone. Thanks Calgary for bearing with me on that. I know the remote thing wasn't going great in the beginning, but yeah, thanks.